All right, so we are now recording. We're on lesson 4, properties of logarithms. Okay. Um, what you have here in your notes is a list of all the logarithm properties. Some of these should not be surprising to you. Sorry, reading not working the way I want it to. Get my pens. Where's my pens? Sorry. There we go. Okay. What do you know about, okay, so if you think about it, raising something to the power log base b, actually let me start with number 2. Okay, evaluating the log. Logs and b's are inverses of each other, right? So when you do them to each other, they undo what you did, right? So if you think about number 2, since we've already looked about this, I want to do log base b of b to the m, all right? And so to do a log, what you're asking is you're saying b to what power is b to the m? So it would be m, okay? Let's put the cell phones away. Yes, that's not important. All right, m. So a log and an exponent, because they're inverses, they undo each other. So whenever you have log base b of b to the m, right, or b to log base b of m, so when they're next to each other, they just cancel each other out, all right? So for example, with logs, with ln's, it works the same way. These are really the same rules, just repeated with base e over on the right-hand side here.
So number 2 cancels?
Yeah, so they just cancel each other out. So for example, if I had log base 2 of 2 to the x, when they just cancel each other out, you get x. Okay? So because they're inverse properties, whenever they're next to each other, they just basically cancel each other out. Okay? So we'll take a look at that. Now, when you multiply exponents, what do you do with the exponents? You add them. So I want you to look at this. This is kind of that idea, all right? If you think of them as exponents, all right? When you multiply exponents, that turns into addition, all right? Or when you add 2 logs together, you can go both ways, all right? So so multiplication turns into addition, all right? The next one is division. Well, what do you do with exponents when you divide? Subtract them. So division turns into subtraction, all right? And there's an interesting one. This is kind of like a power to a power. What do you do with powers? Multiply. So this k here, this comes out front, you multiply it by the log. All right, so these are your log rules. They've repeated over on the right with ln's. They're the same rules, they just have a different base. Okay, I don't care what the base is, all right? You're going to need to know these rules because that's what we'll be using over the next few days, all right? But they're a lot like exponents. So we're going to use our rules, properties 1 and 2. Basically, this is this idea that if I take them next to each other, they're just going to undo each other. So if you look at number 1, you have 5, log base 5 of 18. So what happens with the 5 and log base 5? They undo each other, right? So what you get is 18. Okay. So the next one, guess what that one is? I heard you say it louder. X minus 2, because these guys cancel, right? They undo each other. All right. And E and ln are inverse functions of each other here. So they effectively cancel each other out when they're next to each other, and you get 13. Okay? Makes a lot more sense with examples. All right? When they're next to each other, they just cancel each other out. Okay? And we'll be using that when we solve equations too. Is that all right? Okay. All right. So use properties of logarithms to evaluate each expression without using a calculator. So this is the same thing. What happens when they're next to each other is they cancel each other out, and you get 3. Okay. Now this one looks hard, right? Yes? Okay, we have a couple options. What I would do is to what? Yeah. So you want to do like the first one, right? And when you add exponents, it turns into multiplication, right? Would you agree that what I wrote in number 5 are the exact same thing? Because what do you do with the exponents here? Going from here to here, what do you do with the exponents? When you multiply, you add. See if they're the same thing? All right, this one's easy. What's 4 log base 4 of 6? 6. That's easy, right? Now, this guy, you have a problem. Here's your problem, right? You have a 2 in the way, so the 4 is not directly next to the log, so you can't just say it's 3 or 6 or whatever. You have to figure out how to get rid of the 2, all right? This comes down to a log rule. So we're going to go back to the rules. Is there a way I can get rid of a number out front of a log? What rule would do that for me? Let's ask you that, 1 through 5. Good, 5, okay? See, what happens is I can take this K and I can take it up top and make it a power, right? So that's, I'm going to get rid of that too. All right, so let's use that log rule. Oh, gotta go back. All right, so this 2 can come up front. So what I have is 4 to the log base 4 of 3 squares. Yeah,
Why
so
do
you
you have a 4 in front?
Huh?
Why do you have a 4 in front?
the 4 is just the exponent. All I'm doing is working on simplifying this part right here.
Yeah, but where did you get it from?
Because I go to my exponent rules, right? The 2 sums turn into it's a product of logs, right? So I need a base. Right, here. This is an exponent. X to the a plus b is x to the a times x to the b. Does that get where the 4 comes from? I just went the other way. Okay? Alright, is that right? Alright, so I'm just working that log. So now that I've got the 4 and the log base 4 next to each other, they cancel. And so I get 3 squared, which is 9. So 6 times 9 is 54. Okay? Now that is not the only way I could have done that. In fact, let's do it another way, just to convince you. Sometimes there's more than one way to do these. You've got, I'm just going to work with simplifying this expression of the exponent. Is that all right? Let's just work some log rules. So I would like to get that down to 1 log. Okay. Would you agree, since we talked about that first rule, that basically k log base whatever of x is the log of x to the k? That would be our 5th rule, right? So can I take the 2 up top here, right, and make that 3 squared? Okay, so what I have is the log base 4 of 6 plus the log base 4 of 3 squared, which is otherwise known as 9, right? So you have the log base 4 of 6 plus the log base 4 of 9. Now, there's a rule for sum of logs. Do you remember what it was? Let's go back and look at, see if we have a rule for sum of logs. Okay, which rule has a sum of logs in it? 3. So the sum turns into a product. It's just the log of their product, right? So we're gonna use that. So where'd it go? So this would be, I'm gonna come over here. Log base 4 of 6 times 9, which is what? 54. Yeah. So I can replace that now in my expression. So what I have is 4 to the log base 4 of 54, and guess what that is? It's still 54, okay? So there's more ways to work these than sometimes, you can see it a different way than I do, and we're all good. All right, we hear that? Okay. But you see, you gotta know these rules. So when you're working your homework, I would keep these rules handy, because until you memorize them, you wanna have them handy. Yes, you want to do homework. All right. So now that we're kind of getting a feel for this. Now, a lot of times what they want you to do is write something as a single log, all right? So what you want to do is, if the idea is to use the log rules to get it down to 1 log, okay? So the first thing you have to do is any coefficients out front, they turn into powers. All right, that's that 5th log rule. So we're going to take the 1/3, the negative, we'll take the 1/3, what are we going to do with it? Put it outside, right? Make it up here, yes? So what you have is log base 2 of 48 minus log base 2 of 27 to the 1/3. Okay, well what's 27 to the 1/3? 3, right? It's cube root. So what you have is log base 2 of 48 minus log base 2 of 3. Okay? Do we have a rule for subtraction? Yeah, subtraction. What rule is it? What number? 1. Okay, no, it's not 1. What rule is it? We're gonna go back. It's rule number 4. Okay, subtract subtraction turns into division. So what we're gonna do, so this is log base 2 of 48 divided by 3, right? Is that right? What's 48 divided by 3? Too many, no.
16.
16, all right. And is that something we can evaluate? Sure, right? 2 to what power is 16? 4, so that's the answer. Now, they only wanted me to write it as a single log, we just need a little bit of practice. Okay? All right, you see I'm just using these rules? That's all I'm doing. I have to know them. All right? This is why I recommend very strongly that you practice, all right? You do your homework because you're gonna have to practice this. You won't get them otherwise. All right, so here's the nice thing. With number 7 here, so coefficients become powers, well, we'll deal with that in the end. I want to deal with the thing in the parentheses first. We better use PEMDAS, right? PEMDAS, parentheses, all right? So do we have a rule for sum? Yeah, we do. Sum turns into a what? Product. So I can combine these two and make it the ln of 3 times 6. Okay? And so I have the ln of 18 minus the ln of 2. What about the subtraction? Turns into division. So would it make sense I have the ln of 3 times 6 over 2? Oh, times 1. All right, so let me make a generalization for you. When you have a sum, anything that's positive, like the 3 and the 6 are going to go on the top. Anything that's negative is going to go on the bottom. With 1 log. Isn't that nice? So positives go on top, negatives go on bottom. Okay? So I get the ln of 18. Is that right? Yeah. 1/2. So what do I do with the 1/2? Pull it up here, right? So it'd be the ln of 18 to the 1/2, or basically the square root.
Did you divide by 2?
Huh?
You didn't divide by 2.
What do you divide by 2?
3 times 6.
No.
So it would be the square denominator.
Yeah, I made a mistake. All right, sorry. Because it's 18 divided by 2. It's 36 divided by, no. This is not 36. That's why I'm getting this 3 times 6. It's 18 divided by 2, right? All right, so it's 9. And so then I get the square root of 9, which is 3. All right, so there's my 1 log. Okay? So, you just got to use these rules. The sum turns into a product. A difference turns into a quotient. Powers can come up top.
Oh,
All right? Is that all right? I'll be all right. Okay. Expand as much as possible. So when they say expand, I want to write it with as many logs as possible. When you get to calculus, you'll have a reason for this because they would much rather integrate the expanded form than what this is. Okay? So I'm going the other way with the rules. Okay? So a product turns into a what? When I expand, addition. So the ln, I could write this as the ln. Actually, let's deal with subtraction first, then look at division turns into subtraction. Right? Is that okay? And multiplication turns into addition. So this would be the ln of x plus the ln of y minus the ln of z, and I'm expanded. So anything that's on top is going to be added. Anything that's on the bottom is going to be subtracted. That's all there is to it. Okay? That's it. Okay? All right. You got to be a little careful with number 9 because there's no rule for this part right here. We have to be careful with that. So we're just going to follow the rules. All right. What am I dealing with? Multiplication, division, multiplication, right? So you have x times that mess, right? So first thing I'm going to do is turn that into addition. So it'd be the ln of x plus the ln of the square root of 1 plus x squared. All right, and there's not a lot more I can do with this. I'm going to write the square root as 1 plus x squared to the 1/2. And what can I do with the 1/2? Is there something I can do with it? It comes out front of its ln, not out of the whole thing, not over here, but in front of its log. Okay? So it'd be the ln of x plus 1/2, the ln of 1 plus x squared. And that would be expanded. There's no rule for this, right? There's no rule for the log of a sum, right? We have a log of a product or the log of a quotient, but no rule for the log of a sum, so don't mess with this. All right, we good?
What if we don't do that last step?
Huh?
Could we leave it at plus?
Like this? They're gonna want you when you expand to pull these out front, to pull the powers out front, all right? That's just kind of your last step. So like when you compress, the powers went, the numbers went to become powers. When you expand, the powers come down, all right? Yeah, they're gonna want you to do that. It's gonna be important in your calculus. All right, so note log m plus n, there's no rule for that. Don't ever mess with the log of a sum, right? We have the log of m plus the log of n is the log of mn. So we have a rule for the sum of two logs, but we don't have a rule for the log of a sum, so we just don't mess with that, okay? That's probably the most common mistake people make. Okay. I think that's it.
Yeah, that's it.
All right, good. All right, so I'm gonna put this up online so you can watch it if you want to, okay? All right, that's it. Let me stop recording. All right, so we did 2 sections tonight. You should do, where's my recorder? Let me close that. How do I stop recording? Well, that would be a problem.